So there are many, many different ways that a threat actor could cause harm to a manufacturer. So given that, what can organizations do?
Well, some scary thoughts there, Darren, but yeah, organizations need to then think about how do we secure these devices, yeah?
And then from a brand and reputation perspective, if we think about an organization that has some intellectual property, maybe it's a recipe that is their brand, then having that locked down or exfiltrated and then shared with the world, it's catastrophic for an organization.
Absolutely. So secure networking is the way to go. Providing the security at the network, right up close to that point at which that device connects to the network. And we can do that multi-layered. One of the layers we can take is around zero trust access. And this is about, let's say someone remotely needs to access one of these OT devices to do some level of maintenance or to extract some data. And they are people who work for the organization, but before we establish that connection, let's do that check. Are they who they say they are? We can do that through multi-factor authentication. We can have rule-based access to make sure they can only access the things they're permitted to access. We can also check the device itself. What device are they using to connect to that OT network? Has that device been compromised? Is there any vulnerabilities? Can we do a scan on it to check if there is any vulnerabilities before we establish that connection? And even after the connection has been set up, can we check the content of the data that's been passed from that remote user outside of the factory floor, if you like, now connecting inside to this really quite critical, certainly to the business, like you said in some of the worst case scenarios, but it's critical infrastructure.
Absolutely, yeah. So when we think about zero trust networking access, it's a bit of a buzzword and has been for a while now. It really is that ability to be able to say, right, Pat has access to this system because of his role, but to your point, is the device that he's using secure? Does it meet the minimum compliance standards from a corporate perspective? Is it patched? Is it updated? Is it running the correct firmware? And is it running a antivirus, anti-malware software as well? So from a conditional access perspective, it's really important that we understand that we can start to bring these technologies to bear to make sure that it's not a one-size-fits-all anymore in terms of trusted behavior. Darren accesses the network and he passes a single control point, which is a firewall or a username and password, single factor, not multi-factor. And because I have done that, now I have access to everything. That's trusted behavior. This is where zero trust comes in. So we do not trust that at all. We constantly verify, and we assume breach in most instances, which is the level of scrutiny that we apply to that connection. So yeah, I can see that.
Exactly that. And then to take that to a level further, we can talk about network segmentation. So you mentioned the firewall, which is pretty standard in every organization to protect you from the internet. But what about inside the network, right? We talk about east-west traffic. That's where there may be sub-networks behind that may be bad actors or compromised devices that are already behind the firewall could potentially propagate attacks between networks inside the organization. So how do we protect against that? It could even be within the OT Purdue model, where we've got different layers of assets that we've categorized. So the ICS, the industrial control systems, the SCADA systems, we want to protect them more than maybe the sensors. So how they communicate between each other, we need to make sure that a compromised sensor doesn't actually then propagate an attack and compromise one of those more critical SCADA systems. So that's about a network segmentation, and we can take that to a level where we go right down to micro-segmentation and then define who's connecting to those micro-segmented networks, those devices, where they're connecting from, and build policies, real fine-tuned, granular policies around just that.
Yeah, it's interesting, isn't it? Because there what we're talking about is separating and segregating traffic at the Purdue model. I will get you to explain that in a second. But from an industrial control system, base component of a programmable logic controller, how does that talk to the SCADA system? If that is compromised, how do we limit the amount of traffic or limit the threat in terms of what that particular thing can talk to? Segmentation can be an answer. So we just allow that particular device to talk to that particular system. and limit that ability to go east to west, as you described it, to compromise other systems. And to my mind, it's really improving the level of security all the way down through the model that you described, coming away from an IT/OT boundary, which is typically what we see today in our customers, and moving to a much more fine-grained solution whereby we really get down to the nitty-gritty of what can talk to what, assuming the worst-case scenario, and making sure that we can still keep that factory running and being productive.
Absolutely.